Okay, so we're going to talk about limiting reactants, or reagents. Same thing, right?
Okay.
Reactant, reagent,
Okay.
all good.
Good to know.
Okay, yeah. So whenever we have a problem, generally, at some point it's going to end, right?
Right.
It's not going to keep reacting forever.
Right.
Okay, so something is going to run out.
That makes sense.
And whichever one runs out first is the one that is limiting.
So that's the one that's going to stop things.
Right, it's
Okay.
limiting how much can be made, right?
Okay. That makes sense.
So we generally call that the limiting reagent or reactant.
Okay.
Okay, so before now it was always worded as this is in excess. Okay,
I noticed that.
yeah, it's
okay.
always says it's hey in excess, so that would be the one that there was more of, there was extra of.
Okay.
Okay, so now you're generally not going to be given which one is in excess, and you're going to have to figure out which one has extra and which one is actually limiting how much can be made.
Okay.
Okay, and so basically we're going to have to do two sets of problems here. Sorry guys, you're going to have to do stoichiometry twice.
But that's not anything new.
It's
I
not.
mean, we've been doing that. We just have to do it
We
twice.
have. It's the exact same thing you've already been doing. You're just going to be doing it twice in one problem, which
Okay.
I know makes y'all mad, but you just got to do it. And we were nice, and we're only making you go from moles to moles.
Yeah, I heard Miss Copeland's making him go
All
from
the
grams to
way.
grams.
All the way, and it's so.
Yeah.
And yeah, so you guys take a deep breath, calm down. It's not that bad. Okay? So here's our first example. If I start with 25 moles of lead nitrate, okay, and so I'm going to go ahead and identify right now lead nitrate is
Okay.
one of my givens.
All right.
Okay, the difference with this one is that I'm going to have two givens.
Because you said we'd have to do it twice.
Right.
Okay.
Okay, and I'm still going to only have one wanted, so they're actually going to end up in the same place,
Okay.
which actually makes it a little easier because the last things you're writing down are going to be the same.
Oh, okay. That does
So.
make it easier.
And personally, I like to kind of identify these as I go. So lead nitrate is going to be the PbNO3 one.
Right.
With the two. Okay, so I don't even have to think about it because it's already up here. And then the sodium iodide is the NaI.
NaI. Okay.
That one. Okay, and the one I want is sodium nitrate, which is this one over here. So basically, I'm going to do the math twice.
Right. Okay. So we start with the first given, so we can say that's the 25 moles of the PbNO3.
Yep.
Okay.
And again, it doesn't really matter which one you start with, but I like to kind of go in order so I know what I've done.
Yeah.
Personally, 25 moles of PbNO3, 2, okay? And I want to change that to
Moles of the sodium nitrate.
which
Okay.
we said was NaNO3,
Okay.
okay? So if I'm going to moles of sodium nitrate, I'm coming from what?
Moles of PbNO3.
And so
2. Okay.
where am I going to get my molar ratio?
We have to look at the coefficients
Exactly.
in the equation.
Exactly. Same thing we've already been talking about again and again.
Okay,
And again.
okay.
That molar ratio, right? So NaNO3 is right here. It's a 2.
Okay.
And there's nothing in front of this one, so what is it?
We can say that's 1.
1.
Okay.
And then you just do the math.
Okay. That wasn't too bad.
So 25 times 2 is going to be
50
50 moles
moles of.
NaNO3. Okay, so watch that because that cancels out.
Right. Okay.
So basically we just need to do it again
All right.
for our other given, which is
15 moles of NaI.
Okay, and again, I want to change it to the same thing.
Okay,
So it still needs to say moles of NaNO3 right here,
right.
which we already established was 2.
Yeah, okay, so that's not changing.
No.
Okay, so then on the bottom we want moles of NaI,
Mm-hmm.
and we look at the equation, and 2 is in front of the NaI. So
Yeah.
that's the number we need to write in down there.
Right, so this one is going to be 15 times 2 divided by 2. Okay, so
Carry
you
the
can
six.
actually do the math if you want. 15 times 2 is 30, divided by 2 is 15
15
again, or we can recognize that 2 over 2 is 1 and it's just 15.
Okay,
So this is 15 moles of NaNO3.
okay.
So which one made less?
The 15 moles of NaI, because we only ended up with 15 moles
Yeah.
versus the 50
50.
moles with the
Yeah.
PbNO3.
So which one limited the reaction?
I'm going to go ahead and say the NaI, the sodium iodide.
Yep. And that's as easy
Wow.
as it is.
That actually is
Yep.
a lot easier than I expected it to be.
And we're not even making you find how much was in excess. So high five.
Oh, yay!
Okay.
Wow,
so,
okay.
Yeah, that's literally it. You're gonna do moles to moles twice,
Wow.
and whichever one makes less is your limiting
That's the
reaction.
limiting. Oh,
That's it. It ran out. So
okay, cool.
all right. So we're gonna do some guided practice. If you want to pause and see if you can do it on your own, do so now. Right?
Right.
We can do our little Jeopardy. Do, 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 do. Okay, we're back.
Okay.
Okay, so guided practice. And again, we're going to go through and identify our givens.
All right. So we've got 1.26 moles of copper.
Okay, so that's one given.
The other given would be the 0.78 moles of sulfur.
And what do I want?
Let's see, the maximum number of moles of copper 1 sulfide.
Moles of copper, 1 sulfide. Okay, so if copper is Cu
Yeah.
and sulfur is S, copper sulfide must be which one?
Must be the Cu2S.
S, yay, and that's our one.
Cool.
Okay, so I'm just going to do my math
Okay,
twice.
so we start over. We'll do 1.26 moles of copper as the given.
Moles of copper. And we want to change that to
Moles of copper sulfide, the Cu2S, right?
Yep.
We want to have
so
moles of copper on the bottom.
because we got to cross out, right?
Yeah. And then we look at we take the coefficients, so there's a 2 in front of the copper. And
Nothing in front of that.
so we say it's 1.
1.
All right.
So 1.26 divided by 2 is
0.63
yep,
moles.
moles
Because we got to put the units.
of.
We switch to Cu2S.
It's important to put what you're dealing with.
Yes.
Okay. So next one we're gonna do is what do we start with?
0.78 moles of sulfur.
Sulfur. And again, we're changing it to
The moles of Cu2S. So that means on the bottom we want to
same
have
thing, right?
right, and then on the bottom we want moles of sulfur.
Which there's
There's
nothing
nothing there,
so
so we put 1.
And so that one's easy, right?
That's really nice. So 0.78 moles of Cu2S.
Okay. So which one made less?
The one that made less was the copper. So
This one.
so that would mean copper is the limiting reagent.
Copper was limiting, and so this is actually the maximum amount that we could have made. We could not have made the 0.78 because we ran out.
Okay, that makes sense. So we would run out when we hit that many moles of Cu2S, we'd run out of copper, so everything
Right.
would stop.
Exactly.
Even though we've got
More sulfur.
more sulfur.
Yeah.
Okay.
So you'll have both of these answers, guys, so you do need to indicate which one is the actual answer of the question, which is what is the maximum number. So it would be 0.63 would be our maximum.
Okay.
Can't make any more. So it does need to be indicated that that is your correct answer.
Oh, okay.
Okay?
Yeah.
So don't just not indicate which one is which. I want you to actually tell me this one is it,
Please.
please.
All right.
Okay. Next guided practice.
All right, so let's see. Dun, 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 dun. I'm seeing
We are
0.36 moles of hydrogen, and
H2.
I am
It's a
seeing
given.
another given of 0.23 moles of silver,
Mm-hmm.
which is Ag.
Silver's Ag. Okay.
That means we want to get the number of moles of hydrogen sulfide. So moles of hydrogen sulfide is what we want.
That shouldn't say silver. That should say sulfide.
What?
My bad. Okay, imagine that says sulfur, and it's an S. Yes, sulfur. That's totally my bad. Okay, so anyways.
Do what we write,
Yeah.
not what we type.
Oops. Moles of hydrogen sulfide is definitely what we're looking for, right?
Yes.
So, again, but what we're starting with, H2.
Right. We want the moles of hydrogen sulfide,
Which is H2.
and there's no coefficient next to that H2S, so we just write a 1.
1,
Okay. Moles of H2 is what we were
so that they
given.
cancel out.
And there is no
Nothing there
number there,
again,
so that's nice.
Yay! So this
Okay.
is 0.36.
Moles of H2S.
And then we have 0.23 moles of sulfur.
Sulfur, not silver.
Not silver. And again, I've got moles of sulfur, which there's nothing
There's no,
here.
okay, so we can just put 1. And we're sticking with mole of H2S. 1 mole of H2S, that didn't change.
So 0.23.
I'm going to go out on a limb here and say that the sulfur, the not silver,
Yeah.
is the limiting reagent. And the
Yay.
maximum that we can make is
0.23
0.23 moles of
Yeah.
H2S, the hydrogen sulfide.
So that one was super easy because everything was ones.
That was really nice.
Okay, so yay!
Work on your practice. If you have any questions, come see us.
We're here.
Otherwise, sally forth, young adventurers. Wear your seatbelts.
And be kind to animals.
That's a good one. Okay.
Okay.